Hey everybody, prepare to be amazed. From groundbreaking designs that defy traditional norms to technological advancements pushing the boundaries of flight, here are the top 15 most innovative aircraft air taxis. In the future, there is hope that air taxis can help ease congestion in urban areas, and to date, the Airbus City Airbus Next Gen may just be our best shot at making this dream a reality. Unveiled in March of 2024, it's powered by 8 propellers and 16 electrical units. When in flight, it can carry up to 1 pilot and 3 passengers for a distance of 80 kilometers and at a cruising speed of 120 kph. Best of all, it doesn't need much room to take off or land, making it perfect for urban use. Maybe I'll get one in my backyard. Number 14, the B-21 Raider. So for the past 25 years, America has relied on the B-2 Spirit for bombing missions. This has given China and Russia enough time to build competitors. In response, the U.S. has recently debuted the B-21 Raider. Designed to fly, and while there are plenty of them out there, one of the most innovative is undoubtedly the Boeing MQ-28 Ghostbat. Built in Australia, this unmanned combat drone makes full use of AI, and it's able to communicate with America's new 6th-generation fighters and bombers. It's got a range of more than 3,200 kilometers, a combat radius of 1,400 kilometers, and it's got an integrated intelligence, surveillance, target acquisition, and reconnaissance suite. Best of all, some reports state that it can even operate in space. However, to date, many of the details aren't public information. Number 12, the X-37B Orbital Test Vehicle. So of all the entries on this list, few straddle the line between being an aircraft and a spacecraft, quite like the X-37B Orbital Test Vehicle. So it is shrouded in secrecy, but what we do know is it's carried secret payloads on long-duration flights in Earth's orbit. It also launches from Earth like a spaceship and re-enters Earth as a space plane, making it pretty innovative. Best of all, it was the first in business aviation to be completely carbon neutral. It also has an eco-friendly interior and sustainable aviation fuel, well, in other words, a novel blend of conventional jet fuel and synthesized blended agents from liquids such as cooking oils, plant oils, and wood waste. And while this plane may not be perfect, it certainly is an innovative step in the right direction. However, at a cost of $27 million a pop, only the ultra-wealthy can afford this thing. Number 10, the DJI Mavic 3 Pro. So while most of the aircraft on this list are far out of reach of the average consumer, the DJI Mavic 3 Pro is great if you want something that's on the cutting edge of consumer-class drone operation. Most drone owners want a top-tier camera. In this area, the Mavic 3 Pro doesn't disappoint. These drones are equipped with a 24mm wide-angle lens with a 4/3 sensor and a camera array of 2 telephoto lenses. Now, thanks to the larger sensor on this camera, the drone can capture tons of images in detail in practically all lighting condition potential problems, such as small tree branches and wires. The drone also has an advanced pilot assist system. This system essentially allows the drone to fly around obstacles by itself. And while it's not perfect, after all, it occasionally pauses in place in front of large buildings. It more or less works as advertised. Now, this isn't to say that there aren't any problems. After all, its base model has just 8 gigabytes of storage, and its battery life of 43 minutes is not only relatively low, but according to some reports, only achievable in perfect weather. The drone is also heavy enough to require FAA registration. While it only costs $5 every year, that's a bit of an annoyance to file. After all, at a price of $2,200 a pop, it certainly is an investment. Yet if you want the best of the best in terms of retail drone tech, then this one's hard to beat. Number 9, the HY-4. So in recent years, there's been a push to create planes that are more sustainable, and the HY-4 is one of the more innovative options on this list. Equipped with an electric motor powered by a hydrogen fuel cell battery system, this setup manages to get the aircraft to a cruising speed of 145 kph and a max speed of about 200 kph. It can maintain its cruising speed for some time, while its range varies depending on the speed, load, and latitude. It generally falls somewhere between 750 and 1,500 kilometers. Now, one notable thing about this aircraft is it's incredibly eco-friendly. The hydrogen fuel cell is stored at pressure between 4,300 and 5,800 psi in 2 carbon fiber tanks. The fuel cells convert hydrogen directly into electrical energy, and the only waste product from the process being water. While the aircraft can therefore fly emissions-free so long as the hydrogen for the fuel cell is properly produced. That is, through electrolysis powered by renewable energy sources. According to H2Fly co-founder Joseph Callow, quote, "We're now looking ahead to scaling up our technology for regional aircraft and other applications, beginning the critical mission of decarbonizing commercial aviation, the F-35 Lightning II." So there's lots of debates as to which fighter jet is the best. As of now, the general consensus is that the F-35 Lightning II is the most powerful to ever be built. While it's an integral part of America's stealth aircraft fleet, these jets are made by Lockheed Martin and serve the air forces of the United States, Canada, Australia, and many European countries. They're able to reach speeds of up to Mach 1.6 and fly for distances of up to 2,800 kilometers. The F-35 is one of the fastest jets out there, and it's exceptionally difficult to detect, and it's so stealthy that its radar cross-section is the approximate size of a golf ball. Now, on board, the F-35's armaments are minimal but capable. Generally speaking, these planes have one 25mm gun and a combination of between 4 to 10 missiles. Now, from a numbers perspective, this may seem pretty small. However, this amount of armament is perfect because the F-35 is designed to be a discrete fighter. For example, one of its more six, the first F-35s to see battle, fought in 2018, when Israel used the jets to conduct strikes in Syria against suspected Iranian supporters of Hezbollah. The Israelis also confirmed that they used the jets to shoot down 2 Iranian drones, and it's widely believed that they were also used to combat Islamist militants in the Egyptian Sinai and Hamas arms smugglers in the Sudan. Most recently, they've also seen use in the Israel-Palestine conflict and during Israel's offensive airstrikes on Yemen. So, while the F-35s are mainly used for deterrence, Israel has shown they can have a real impact in battle. Moving on to number 7, the cooking oil airplane. So the Airbus A380 is one of the world's largest commercial planes in use. After all, it is still used extensively by luxury airlines such as the Emirates, Etihad, and British Airways. Yet despite its large size and penchant for luxury, this plane also is quite green. This was proven in March of 2024 when one new planes to be built. Generally speaking, they also produce much smaller carbon footprints over their life cycles because they're not produced by fossil fuels. Depending on the SAF, they can reduce emissions by more than 90%. Now, while these SAFs may seem like a magic solution, there are some serious concerns about them. One is that oftentimes land will be used to grow crops for biofuel. This is a problem because it prevents the land from being used for food crops. This in turn may lead to the destruction of forests and peatlands to create these SAFs. The loss of the trees and plants that absorb carbon would therefore increase the carbon footprint and in many ways neutralize the positive impact of SAFs. As a result, SAFs cannot be the only answer. While we certainly need to move towards creating planes with electricity and hydrogen and must work to encourage rail over air travel, SAFs can be part of the solution. But by making fossil fuel aircraft a bit greener, SAFs can in turn reduce their environmental impact, maybe helping ensure that propellers or turbines. The light aircraft is powered by an ionic wind, that is, a silent but mighty flow of ions that's produced aboard the plane that generates enough thrust to propel the plane over a sustained, steady flight. MIT managed to pull this off by designing a small 2-kilogram airplane with a 5-meter wingspan. The plane had a series of thin wires with positively charged electrodes and thick wires with negatively charged electrodes. These were attached to a stack of high-powered batteries. These specially designed batteries managed to supply 40,000 volts of electricity, thereby positively charging the wires via a lightweight power converter. Once these wires are energized, they interact with the negative electrons in the surrounding air, sucking them in. This in turn makes the air positively charged, which in turn attracts the negatively charged electrodes at the back of the plane. This process causes clouds of ions to flow towards the back of the plane, and as these ions collide, this creates thrust. When tested, the MIT team flew the plane a distance and that they don't create any noise pollution. Yet, the ionic wind technology still has a way to go. As put by MIT professor Stephen Barrett, quote, "This was the simplest possible plane we could design that could prove the concept that an ion plane could fly. It's still some way away from an aircraft that could perform a useful mission. It needs to be more efficient, fly for longer, and fly outside." End quote. Well, with that in mind, drones may be the first aircraft to give the go-ahead to use ionic wind. However, whether or not this technology will ever become widespread is yet to be determined. Number 5. The Karabil Maquette. The Soviet Union's Karabil Maquette had the potential to completely change aerial warfare. Absolutely massive in terms of size and scale, it was one of the vehicles created by the Soviets in an attempt to outdo America during the Cold War. And while their efforts ultimately failed, this vintage aircraft stands as an example of the Cold War spirit of innovation. Nicknamed the Caspian Sea Monster by American, at a certain distance from the ground, they experienced reduced drag because the airflow around the vehicle interacts with the surface below. This then creates a dynamic cushion of air that can increase lift by as much as 40%, while allowing the aircraft to have much smaller wings. As such, it was neither a plane nor a boat, but a mix of the two. And given its 8 enormous engines, length of 100 meters, and ability to fly at speeds of 430 kilometers an hour, it was truly a scary sight for American military personnel. Yet, despite its impressive stats, it really never served much of a purpose. While initially designed as a cross between a cargo carrier and a coastal defense vehicle, the Soviets never quite got the design right, even after a plethora of tests. It's because of this that when the monster crashed in the Caspian Sea due to pilot error in 1980, the Soviet Union didn't try to recover it. However, it is worth noting that it wasn't the only Ekranoplan to be launched by the Soviet Union. That's because in 1987 they launched the Lun-class Ekranoplan, while meant to be an upgrade to the Korabels and liters of fuel. For reference, that's enough to power more than 40 cars for an entire year. Well, this has led to a real push to build solar-powered planes. On a smaller scale, these efforts have sometimes worked. One notable example is the Solar Impulse 2, created and led by Swiss engineer and businessman André Buschberg and Swiss psychiatrist and balloonist Bertrand Piccard. The goal behind the project was to create a solar-powered airplane that could circumnavigate the world. After taking 12 long years and using a team of 50 engineers and technicians alongside 80 technical partners, they created the Solar Impulse. After using those hundreds of specialists, over 100 suppliers, and taking 5 years, the team managed to create the Solar Impulse 2. Supporting a wingspan of 72 meters and using an array of 17,000 solar panels to absorb energy, it was a success. Not only was it incredibly efficient, but it managed to reach speeds of up to 140 kilometers an hour. And in 2015 and 2016, it traveled across the world. A technology-related accident happened, causing Helios to break up and fall into the Pacific, about 16 kilometers west of Hawaii. Now, while all these solar aircrafts have served as great templates, the million-dollar question is whether or not these small-scale projects can be transferred to the commercial level. The unfortunate answer, in brief, is probably not. According to Associate Professor Rhett Allain of Southeastern Louisiana University, in order to get a larger passenger plane up in the sky with solar power, you'd need a ton of energy. Using a Boeing 737 as an example, you'd need, even in perfect conditions, 29,000 square meters of solar panels. Since the 737 has a wingspan area of just 125 square meters, that simply isn't feasible. For reference, that's about 0.4% of the power you'd need to remain in the sky. Well, thankfully, that doesn't mean that there's no hope for green energy on planes. After all, as you've seen in this video, greener planes are possible. But the sad reality is that without a hell of a lot more innovation, solar-powered planes for a 3-day stay. Yet for those who want to reach the edge of space but don't need to be up close and personal with it, there may be a more economical option: space balloons. And as of now, there are 2 main competitors in the market. The first is Zafalto's Celeste balloon. Headed by a French aeronautical engineer in partnership with France's version of NASA, the idea behind it is to bring people close to space without emitting a lot of carbon. The altitude the balloon will reach is 25 kilometers, according to Vincent. This is because it's at this altitude where you're in the darkness of space, with 98% of the atmosphere below you, so you can enjoy the curvature of the Earth in the blue line. You're in the darkness of space, but without the zero-gravity experience. Now, it should be made clear that it isn't actually going to space. After all, while an altitude of 25 kilometers is pretty high, the internationally accepted point of space, known as the Kármán line, is at an altitude of 100 kilometers. Yet it still provides that illusion, and in a luxury setup at the top, and for that price you get access to Wi-Fi, a world-class culinary program, plush safety seating, luxury amenities, and panoramic views through the largest windows ever to be flown to space. Well, unlike the Zafalto, the spaceship Neptune gets you a tad higher, reaching an altitude of about 30 kilometers, and as an added twist, space flights start and end on the Marine Spaceport Voyager, which is the world's first and only marine spaceport for human spaceflight. Now, if these 2 space balloon companies are successful, we'll likely see continued innovation in this field. It's because of this that, on my end, I wish them the best. Number 2, the Avro Arrow. While the Avro Arrow may not be the most high-tech aircraft by today's standards, it was incredibly innovative at the time. Yet despite its innovation, it was completely snuffed out to the ire of military enthusiasts and Canadian history buffs alike. Now, when you think of Canada, high-quality airplanes probably isn't what comes to mind. After all, with the exception of Bombardier, the Canadian aerospace industry is pretty small, a planet. Many features played into gaining its title. For example, its delta wings offered much more internal room and overall surface area, which in turn gave the jet more onboard fuel and a very strong lift. Another feature was its top-of-the-line internal components. Now, these helped it fly incredibly fast. Reportedly, it maxed out at a speed of about Mach 2. For reference, this was the maximum speed of the famous Concorde jet, and according to some experts, there's a strong chance that the Avro Arrow could have been made to fly even faster. However, in a shocking move on February 20th of 1959, Canadian Prime Minister John Diefenbaker made the controversial decision to cancel the program. This not only put about 15,000 people out of a job, but marked a steep decline in Canadian aviation industries. After all, the development of advanced fighters all but ended after the Avro Arrow's demise. To this day, there are many theories as to why Diefenbaker made the decision he did. One reason was likely the cost. After all, it would have been very expensive to continue the program and the conservative Diefenbaker government to become as obsolete as imagined at the time. However, hindsight is 2020, and in our timeline, Canada instead decided to purchase a series of inferior American products, such as the McDonnell F-101 Voodoo interceptors and Bombark B missiles. Number 1. Flying cars. Now, while flying cars may sound like something out of a sci-fi movie, there have been, in fact, efforts to build them for far longer than you may think. While there were several early attempts, the first by a major automaker was conducted by none other than Henry Ford, known as the Ford Flyver. The hope was that the 1927 model would be the Model T of the air. However, this was not to be. After a prototype crashed into the ocean off the coast of eastern Florida, production plans were halted. Not deterred, other auto manufacturers got to work making their own, more functional versions. The first to see success was the Autogyro Company of America's AC-35. This essentially was a gyrocopter that could also drive, and on October 26 of 1936, it was official to public, and only 5 were built. After World War II concluded, various new flying car models were built. However, none saw commercial success due to prohibitive costs and licensing, with the only one being even to see a somewhat significant level of sales being the 1949 Taylor Aero car. After all, 6 were built and 1 is still flying. This drop in interest continued for much of the mid to late 20th century. However, the 2000s have been far more promising, and there are a few especially innovative models that can be purchased by those with some deep pockets. One such example is the PAL 5 Liberty Autogyro. Rather than use wings, this gyrocopter makes use of a helicopter wheel to get around. First debuted at the Geneva Motor Show in March of 2018, it has since entered production out of a factory in the Netherlands. It currently stands as the first car to get full road and air certification in Europe. It's recently gone on in the continent for an average sales price of about 350,000 euros. Best of all, given the fact that they got a range of 500 kilometers, can fit 2 years, the Aeromobile is the stuff of sci-fi dreams. Coming in at a total output of 300 horsepower, it's a workhorse both on and off the ground. On the road, it can go from 0 to 100 kph in just about 10 seconds, and has a top speed that's just shy of 160 kph. It can also travel for anywhere between 500 and 950 kilometers in just one tank, making it suitable for road trips. While in the sky, it can apparently climb at a rate of 360 meters per minute and doesn't need much room for takeoffs and landings. In terms of speed, it would be able to reach a respectable 250 kilometers an hour and have a range of about 730 kilometers with a single occupant and 500 kilometers with 2 people aboard. For reference, that's the distance between New York and Detroit with 1 person aboard, or New York and Toronto with 2. Yet while all this may seem fantastic, many of these cars are yet to launch on a commercial scale, so only time will tell whether or not they will work and sell well. Thanks for watching, everybody. I will see you